Hi and welcome to a Kirby Maths video, and this time it is about bearings and using trigonometry. So you should have watched the first video in this series just talking about bearings, and you should also be able to do some trigonometry, and again there are videos explaining trigonometry on the YouTube channel. So we have an example here, and it says a cat has wandered away from its house on a bearing of 048 for 150 meters, and we want to find out how far north of its start point it is. So there are four simple stages to doing bearings with trigonometry. The first one is to draw the bearing. What I mean by that is draw a simple diagram which summarises the information that you are given in the question. The second bit is to complete a triangle. And the third stage is to use angle facts. That might be to do with the bearings, to do with parallel lines, or to do with right angles. And the fourth is to use trigonometry. And the reason we can use trigonometry, SOHCAHTOA, is because north, south, east and west are at right angles to each other. So we can easily, I've missed that letter there. So we can easily put a right angled triangle in when we're using north, south, east and west. So let's have a look at our cat, and our cat starts off here from home. It walks on a bearing. Now I probably do all my bearing questions with the same diagram, just this angled line, and then it ends up here. This distance is 150 meters, because remember this is just a diagram, we're not drawing anything to scale. And we want to find out how far north it has gone from its start point at home. We have got our north line here on the diagram, and we are told that this angle here, that is the bearing 048. So that angle in there is 48 degrees. That means that if we are to make a triangle here, so this is east, and we drop a line down here, then this angle here is going to be 90 take away 48, which is 42 degrees. And it's this distance here we want to find out, which is the distance north from the start point. What I would then do is draw the triangle without all of this north and 150 and the bearing and everything on it. So a simple right angle triangle, which I'm then going to apply my trigonometry to. So the right angle is here. This is the distance we want. This is 150. The angle here is 42. And then I label up my triangle as if I am going to try and work out which trig ratio from SOHCAHTOA I'm going to use. In terms of the angle, this is the adjacent side. This is the hypotenuse, and this is the opposite. So we write down what we have got. We have got the angle, the 42 degrees, and that means in our SOHCAHTOA then we have got the S, the C and the T, because remember they are stored on our calculator. We have also got the hypotenuse, and we want to find the opposite, which is labelled X here. So I write out SOHCAHTOA and I tick off the things I have got. I've got the angle, so I've got the S, the C and the T. S, C and T. I've got the hypotenuse, so I tick off the H, and I want to find the opposite. So it is this ratio here, the sign I'm going to use. And remember, if I write SOHCAHTOA like this, then it helps us put the letters in the right position on the triangle. So my sine triangle looks like this, SOH, and remember you cover up the thing that you want to find when we're using these triangles. I want to find the opposite, so I cover up the opposite, and that means I'm going to do sine of the angle times the hypotenuse. So opposite is equal to sine times hypotenuse, which is sine 42 times 150. So that means that x, the distance north, comes out, if you put this all in your calculator, comes out to be 100.37 meters. And I have rounded that to 2 decimal places because then that's going down to centimeters. Okay, so just to recap then, when we have a problem involving bearings and trigonometry, we need to do these 4 things. We need to draw a diagram so it's in front of us. We need to work out where our triangles are, and we can do that because north, south, east and west are at right angles to each other. I use the angle fact here, that if this was a right angle, I could take my bearing value away to find out the angle that I wanted. And then I had to choose from my 3 trig ratios which one I was going to use, just using normal trigonometry. And I found it easier to take this triangle out of the initial diagram and redraw it. Okay, thank you for watching.